Securing a safe and plentiful water supply, building bridges, developing ways to protect us against the hazards of toxic wastes, floods and earthquakes, seeking innovations that will lead to more reliable and economic construction. The civil engineer deals with the challenges associated with the most basic needs of society, needs that touch our everyday existence. Consider the challenge of our diminishing water supplies. Surface and groundwater supplies are being depleted and often aren't being properly protected. Civil engineers are working on this and are also helping clean up existing hazardous waste sites, while developing solutions to avoid new ones. The large numbers of deteriorating bridges and highways is yet another area needing the civil engineers' attention. And civil engineers are working to help the U.S. regain its prominence in the construction industry. These needs have been identified for more than a decade, and society is recognizing the need to invest in these important parts of our future. In Virginia alone, $10 billion will be spent on transportation in the next decade. $25 billion has been allocated at the federal level for hazardous waste cleanup. And $1 billion per year is needed for bridge rehabilitation and reconstruction. But money alone can't solve these problems. Equally important is the need for a modern civil engineer who can handle the growing complexity of these challenges. This calls for a person with the vision to anticipate new solutions, who understands the best technologies available, and who can communicate with the public. What kind of new technology will be applied to the challenges facing the civil engineer? Computer-aided engineering is one example that has already arrived. The major change in computing is the accessibility of computing power and the availability of advanced computer graphics. The result is that many routine computations and graphics can be efficiently done by the computer for any size of firm or organization. For example, maps for site planning and site layouts can be represented in two-dimensional or three-dimensional graphics using computer-aided design programs. With computer graphics, plant layouts and structural systems can be tested before final drawings are made. With more powerful programs and advanced microcomputers, graphic overlays can be used to visualize the integration of topography, road systems, pipe networks, and flood conditions. A further application for advanced microcomputers includes high-powered analysis. This might include representation of data concerning pollutant transport in groundwater, networking schemes for highway systems, even predicting how building designs will respond to earthquakes. Computers and microprocessors are already revolutionizing the way civil engineers conduct laboratory and field monitoring work. Many tests are now automated, and automatic feedback controls are incorporated into these operations. These new procedures have immediate application in the testing of materials, soils, and environmental work. Computers are also being used to manage the movement of construction equipment and to allow us to keep track of equipment positions and evaluate how efficiently it is being used. Today's civil engineer is also working with many new materials. 20 years ago, concrete strengths were limited to 3,000 pounds per square inch. Through the use of special additives, we can now obtain strengths of 19,000 pounds per square inch. And polymers have become a vital new addition to construction materials. Polymer concrete can be used to rapidly repair defects in concrete pavements and bridges, thus avoiding traffic delays. Polymers also have application as reinforcement grids for soil. These polymer reinforcement grids can be placed at steep angles to support fills. An additional advantage is that these reinforced soil systems can be covered with light-facing elements for an appealing architectural effect, as seen here on this overpass structure. Civil engineering construction is also rapidly incorporating new technology. Underground construction is benefiting from a wide variety of innovations. Tunnel construction can now be done in the most difficult conditions. A modern tunnel shield is a mechanical wonder controlled by a computer and positioned by a laser beam. Management techniques for construction are also undergoing change. For example, operations of a construction site can be analyzed using a video system which is linked with a microcomputer. Each stage of the construction operation can be broken down and analyzed for its efficiency. Bridges are some of the most beautiful structures designed and built by civil engineers. In bridge construction, several new technologies are used. An example is the cable-stayed bridge. These new type of bridges offer economical solutions for building these graceful structures by facilitating construction and reducing the weight of the structure. Bridges also illustrate the genius of the structural engineer who works with the basic concepts of mechanics and materials as a part of civil engineering. Unfortunately, many bridges built in the past have not been properly maintained, while many other bridges are just too old to continue in service. Major bridge collapses have occurred in the past 5 years in New York and Connecticut, and New York's West Side Highway has been closed. It is estimated that 244,000 bridges need rehabilitation or replacement in the U.S., requiring an expenditure of $50 billion.